Hi everyone, I wanted to do a couple of examples for you to follow along with when you're working on your second worksheet that covers the meaning of expressions, trying to set up expressions given a meaning or trying to figure out the meaning given the expression. So I'm going to do one going each direction, and I tried to keep this worksheet not too long, so there's only really a few types of problems. There's some distance, rate, time, and there's some mixture, and then there's a money problem. I'm not going to do a money example because usually that one goes fairly well, but definitely let me know if you don't feel good about it and I can add something. Okay, so this first problem is kind of a classic algebra problem. Likely you've run into some version of it. You should have before, but that doesn't mean they're easy. They're certainly, word problems in general, always challenging. So we're just trying to set up an expression right now, and it's supposed to tell us about the amount of pure silver in a 90-gram mixture that's made up of one type of, let's see, hold on. Things in my way. Y grams of silver that is 60% pure, and the rest of the silver is 35% pure. Okay, so we know we have a total of, oh, pin, I just fixed this, total of 90 grams in the mixture. So that's not 90 grams of pure silver, that's 90 grams of our partially pure silver when we're all done. We know that Y grams of that mixture is going to be 60% pure. We also have some that's 35% pure. And what we want to know is total amount of silver. And this is not a percentage that I'm looking for. This is actual grams. How many grams of pure silver is in the final mixture? So always, this can be a little tricky. So anything you can do to sort of baby step your way up to it if you are getting stuck. So we're going to imagine that we have our 60% pure silver and our 35% pure silver, and they get mushed all together, and we get a grand total of 90 grams of mixture, and we want to know how many grams of that is pure. So this is the mix. So my first thought is, if I want to know the total amount of silver in the mixture, I would get that by figuring out how much pure silver we get from each type of silver that we're mixing in. I want to say alloy, but I don't actually know if that's the right word, so I'm trying to resist the temptation. Okay, so we're going to talk about amount of, so the total amount of silver is going to be the amount from the 60% plus the amount from the 35%. And this is going to be in grams, right, for both of these. The amount of pure silver in grams from each of these two. So I know that I have Y grams of the 60% pure type of silver. So over here, I know I have Y grams of the, what I want to call alloy, of the partially pure silver. If I want to know how much pure silver I got from that, I'm going to need to multiply by that 60%. So if I have Y grams of the 60% pure, and I multiply by 0.6, what I should be getting is grams of pure silver. It's no longer the mixture I'm talking about. It's how much of that mixture is pure silver. Similarly, if I want to figure out how much pure silver I get from the one that's 35% pure, I need to take that 0.35, 0.35, oh my goodness. Oh no, 3.5, okay, good. Scared myself for a minute that I was doing something really bad. 0.35 for 35%. My dog's attacking me again. And I need to multiply that by the total grams of the 35% pure mixture. But I wasn't given that up front. So this goes back to that question of, I know there's Y grams of the 60% kind of silver, and I know there's a total of 90 grams of both of them. So if I want to know how much of that is the 35% pure silver, I'm going to multiply by 90 minus Y grams. So this can be simplified a bit, not really a ton, but I have 0.6 Y grams plus, 35% of 90, man, hold on, where did I put? Should I be being lazy and calculating? I'm going to be lazy and calculator. I thought about it, that might not be that bad, but I don't want to think that hard. So, and in general, word problems go on exams, and you do have access to calculators, so you can be a little lazy about some of this arithmetic as well. I'm not just being rude. 31.5 grams minus 0.35 Y grams. So when I put this all together, I can combine a little bit. I have 31.5 grams minus 35.25 Y grams. And you could just write grams at the end. That's all units attached to all of it. Let's think about in this one what the 31.5 means. I think what we're getting is that if it was all 60% pure, yeah, it is 35 times 90. If it was all, if it was all 35% pure, and this is a plus, that's why I'm mixed up, there would be 31.5 grams of pure silver. It's not, some of it is 60% pure, so there's an additional 0.25 Y grams of pure silver because of that 60% part of the mixture. So that's what we're getting there. Okay, so hopefully ringing some bells. If not, always keep in touch. Always, I want to hear about it. Okay, next one, I'm going to actually give you the expression. Ooh, I might need to throw in some units in here. And we're going to see if we can pick it apart and figure out what the pieces mean. I do need to give you some units right here in hours. Now, I think we have enough info that it's not totally unreasonable for us to sort some of this out. So we have a boat that's making a round trip, and it doesn't matter which direction, but it's going on a river. So let's just pretend it first goes upstream and then comes back downstream. It's 10 miles total. It has to get back where it started. We know that on the way upstream, it's going to go slower than on the way downstream. So that does make a difference in how long each part of the trip will take. But we still know that they have to get back from wherever they went. They have to get back and make a 10-mile round trip. Okay, so looking at this expression, we're trying to figure out, if this is time, what all the bits and pieces of it mean. This is going to be another direction I ask you to look. So one thing I notice in this problem is that the information, I'm given a 10-mile round trip, is not time information. So I need to figure out how that goes into finding a time. So I'm back to my distance equals rate times time formula. And from that, I know that if I want to get a time, I have to divide a distance by a rate. So I'm thinking that the two pieces I have here, the fractions, are distance divided by rate. That's the only way I can get time out of this distance information. So looking at this, one thing is that I have two different pieces being added together. So I would really hope that what I'm seeing is an upstream piece and a downstream piece. That would be the way I would approach this. I would say, okay, if I have different things happening upstream and downstream, if I want the total time, I would add them together. So I will have out of these two a time, and it's either going to be up or down, plus a time, and it'll be the reverse, down or up. So if the first one's up, the second one's down, and we'll think about which is which in a minute, but I'm thinking that's what I'm looking at. I have an expression that represents time. There was two parts to my trip. There's two fractions. I hope one represents the first part and one represents the second part. Okay, so now if I'm saying time is distance divided by rate, let's start picking apart each individual fraction. So this first one, supposedly I'm looking at a distance over a rate and a distance over a rate. And I'm liking my thoughts about that because I was told that it's a 10-mile round trip. So the fact that the distance is hooking to those fives, I think is a good thing. So what I'm seeing here is that it's 5 miles and 5 miles. What I have left to sort out, and in your homework problems, I'll ask you what specific pieces mean, but I just kind of wanted to walk you fully through how one of these distance, rate, time problems work when you're trying to set up for time. On our last week's worksheet, we had some distance problems where we had to multiply rate times time, but if your expression represents time, then you might be looking at distance divided by rate, and if your expression represents rate, you might be looking at distance divided by time. So that will change depending on which of those three things you're actually trying to represent. Okay, so now my question would be, if I'm looking at the rates, I've said one of these things should be upstream and one should be downstream. So I should be able to pick out which is which. If I have a 12 plus y and a 12 minus y, the 12 plus y is definitely the faster rate, right? We're adding, let's assume y is positive. I think that that's fair in this problem. If y is negative, then I guess I would change my story. But assuming y is positive, we're going to say that first one is faster. So if that's faster, that better be my downstream time. And if that's my downstream time, then the second one better be my upstream time. This last piece, I don't know if it's totally fair or not to ask you this in general, but I promise to give you enough information that I am being fair. When I'm doing it for you, I think I'm allowed to be a little skimpy on the information. What generally you'll see is that if you have an upstream, downstream sort of thing happening, the entire influence on that is the speed of the current. So if you're traveling with the current, it's going to speed you up by however fast that current is. And if you're traveling against the current, it's going to slow you down by however fast that current is. The same with airplane problems where you have a wind speed. We are simplifying things a little. Realistically, the current speed might not be perfectly constant, and the wind speed probably, not even might, not going to be perfectly constant. But to be able to start to tackle some pieces of this in practice, we make some of those simplifying assumptions. So what I think I see here is that if the rate is plus y going one direction and minus y going the other direction, that y probably represents the speed of the current, and it would have to be in miles per hour. That's why I threw that hours back in so you could say for sure. If this is time in hours and we know our distance was in miles, then that better be speed in miles per hour. The last question I would have then is what in the heck is the 12? And what should be going on there is if we're adding and subtracting the current speed to that 12 should be the speed of the boat if there was no current. So 12 equals boat's speed with no current in miles per hour. Okay, so I'm just hoping this kind of gets you started, and I would love it if you would come back to me when you run into something that you're not feeling sure about, you need a little more help with. Like I said, we'll keep revisiting this. This isn't something that's one and done. This is me trying to have you think about little pieces of this before we start setting up full equations or building functions. So it's coming back, so do your best with this one and ask lots of questions so that you're feeling good about this one before we see it again next time. Thanks for watching.